In this video, we're going to talk about how we describe data and the ways we do that. So first of all, we have the data classification of quantitative versus qualitative. And as you can see, we kind of indicated already that quantitative is numerical, where qualitative is categorical. So by description, it's data that exists numerically in nature, okay? Meaning that it's naturally numerical. So for instance, a zip code is not numerical data because a zip code is really an assignment of location. It doesn't exist naturally, okay? And it can be used in calculations. So if you were to average the data, that makes sense. Or add the data together, that makes sense. But like if you're talking about zip codes, that wouldn't make sense, right? Adding zip codes together, why? Like you're not necessarily going to produce a new zip code, or it wouldn't make sense to average zip codes. That's not going to give you an average location, okay? So it's natural data, data that appears numerically by nature, like weight or height or length or something along those lines. Okay, so qualitative data is data that's classified into categories or subjects. Whatever makes sense. So an example of quantitative data, as I said, was something like height or weight. It could be something like a counting, like the number of siblings you have, or pets. Here we'll do pets, shorter. Okay, so qualitative being categorical, I already kind of said zip codes would count because that's an assigned fake number that doesn't actually mean anything. Another example could be like a favorite type of movie. That could be an example of qualitative data. And we use two different graphs, to describe this data, okay? Specifically, there's a reason, and we'll kind of talk about it as we do some graphs. For quantitative data, we use histograms. Wow, it's hard to see. There we go, histogram. And a histogram, just a little rough sketch, is the one with the rectangles that touch. But for qualitative, we use a bar graph. Now, a bar graph is very similar to a histogram, but the rectangles do not touch, and that's on purpose. So there is a distinction between a histogram and a bar graph. Visually, the distinction is the touching, but there's also a distinction between one being used for quantitative data and one being used for qualitative data. So the reason we use quantitative data and a histogram, the touching implies intervals of categories. Okay, but we'll talk more about that when we do an example. Before I do that, I do want to mention there's a word we're going to use called frequency. And frequency is the number of times something occurs. So we'll see that word tossed around a lot in this chapter. Okay, so a movie website lists 5-star films, 19 4-star films, 12 3-star films, 7 2 4 1. All right. And we've went ahead and put that into a table. Now we're being asked to find or fill in the information. And I want to kind of explain what this information is. So this phrase, relative frequency. So they've already given us the frequency. Those are the amount of 5-star films, 4-star films, and so forth. But relative frequency means that they want us to come up with a percent. So we need to find the percentage of movies that are 5-star and the percentage of movies that are 4-star and so forth. So first thing that I need to do is total this frequency column. And when I plug this into the calculator, I got 50. And you could plug into your calculator and check. In fact, you should do all of this calculation as I'm going. Make sure that you're getting the same answers I am so that you know you're doing it right. Okay, so to find the relative frequency, I'm going to take that 8 and I'm going to divide it by 50. And I come up with 0.16. Now, I'm okay with leaving the answer as 0.16. A lot of people, though, like to write the percent. So as a percent, it would be 16%. I'll squeeze that in. 16%. Okay, so for the next category, I'm going to take 19 and divide it by 50. Give myself a little space to put that. Okay, so that gives me 0.38 or 38%. And I'm rounding, by the way. So go ahead and finish this. Pause the video, finish it real quick, and I'm going to give you the rest of the answers I got. For this category, I got 24%. 2-star category, I got 14%. And the 1-star category, I got 8%. And that does total up to 100%. Okay, now cumulative frequency. Cumulative implies that you add as you go. So we're going to find each category and the previous category, and that's the cumulative frequency. So for the first category, it always starts off as the same. So there are 8 films total that qualify as 5-star. But the next category, when we look at the 4-star category, we're going to add the 19 and the 8 together and get 27. So what that represents is that there's 27 films that are both 4-star and 5-star. Then we're going to add in the next category, the 3-star films, which is 12. So that's going to give me 39 total. So there's 39 films in those first 3 categories. Then adding 7, I get 46. And then the last category will be the 50 because it's going to be the total. So our 50 films total rated. So that's cumulative frequency. Okay, so we're being asked to create a bar graph and then a relative frequency bar graph and label them. Okay, so here, let me zoom out a bit just so I can see the numbers. There we go. And I'm going to go ahead and draw my axes. So since I'm going out to 50, I'll probably just go by tens. I am asked to give a meaningful title. So here, let me give myself a little bit of space to do that. Let me give myself a title. So I'm going to title this movie star ratings, or just movie ratings by frequency, because we are looking at how frequently they appear. Okay, so it is a bar graph because we're working with qualitative data. And the reason it's qualitative is this 5, 4, 3, 2, 1-star rating, even though it seems numerical, it's not. The 5-star represents a great film, right? Where 1-star represents a bad film. So it's a rating that's describing good to bad. And it's not really numerical. So that's why it's a bar graph. Okay, so we have 5 categories. So I'm going to label those. This is the 5-star, or sorry, I'll probably go, no, I'll go from 5 to 4. So 5, 4, 3, 2, 1. And then this will be 10, 20, 30, 40, 50. Okay, let me label this. And this is 5, 4, 3, 2, 1. And I'm going to label the axes. So this axis is number of stars. And then this axis is the frequency. Oops. Sorry, the computer always has trouble with me trying to write on the side as I'm reaching across. apologize for it being a little sloppy. It's kind of hard for me to write that way. Okay. So let's go ahead and create my little bars for each category. So the first category, 5-star, there's 8 of them. So I'll draw a little oops, it's a little bit too big. I don't want it to be that wide. A little rectangle that goes almost up to the 10. There we go. For the 4-star rating, 19 of them. Oh, I just realized I don't need to go by 10s. I'm sorry. My largest category is 19. You know what? I'm going to go by 5s. That would make more sense. So here, I'm going to erase these. I'm sorry. I hope you did it in pencil. Erase those. Okay. So 5s would make more sense. So 5, 10, 15, 20. And I'll go ahead and just put the 25, even though I don't really need 25. All right. And I'm going to erase this first category here to redo it. So 8 is going to be a little bit taller here. And then 4, the 19, that's going to be right about here, close to the 20. 3 would be 12, so that's going to be between the 10 and the 15. Try to do it a little on the lower side. 2 is 7, so a little bit lower than the first category. And 4, it should be the shortest of all, a little bit below the 5. And there we go. There is my frequency bar graph. Now, to do a relative frequency bar graph is going to be very similar. This time, though, we're going to be doing percentage categories. And I'm going to kind of guide myself using the same ideas because really I want the two graphs to look the same. To do it by percent versus doing it by frequency really shouldn't make a difference. So 5, 4, 3, 2, 1. And then for the percentages, my highest percent being 38%, I think I'll go by 10s. 10, 20, 30, 40, 50. Now that makes more sense for this one. All right, so let me title this. This would be the percent of movie ratings. Or you could say movie ratings by percent. There'd be nothing wrong with that. This is the number of stars. And then this is the relative frequency or percentage. Here, I'll label it relative frequency. But I'm going to abbreviate frequency because of space. And because I'm not putting the percentages, I should probably put the decimals. 0.50, 0.40, 0.30, 0.3, 0.2, 0.1. If you want to put percentages on it, that's fine. If you want to draw the little percent symbol, you could do it that way. Nothing wrong with that. All right, so first category of 16%. Gonna put it up here. Second category of 38% is going to be very close to this one. 24% should be a little bit closer to the 20 if I can do that. 14% should be a little bit lower than the first one. And then the last category, 8% should be just under the 10. Okay, and they look similar, very similar. I tried to make them similar too. So there you go. The two graphs, they really don't make a distinction when you draw where frequency versus relative frequency, as long as you kind of stay consistent with how you space out the tick marks on each. Okay, so let's look at how to do this in Google Sheets. So let me go ahead and share that. I just realized I didn't have my screen ready, so I apologize for that. And I'm going to need to attach my keyboard too. All right, so let me share my screen now. Okay, so coming over here, I'm going to access Google Sheets. And just going to make a blank one. And what I'm going to do is I'm going to create a table of this information. So the movie ratings, I'm just going to kind of copy the table, and I'm just going to do the frequency for each of these. Okay, so 5-star, 4-star, 3-star, 2-star, and 1-star. Okay, and then that went 8, 19, 12, 7, 4. All right, there we go. Okay, so here in Google Sheets, let me go ahead and highlight the table. Okay, now I believe it's under Insert. Oops. Okay, here we go. Chart. Now Google Sheets, if I recall, yeah, it does an auto chart based on your information. And look at that, it actually broke down the percentages for us. It shows a pie chart, but I can change that over here. I can go ahead and ask it to do a bar graph. And it labels the two categories for me. And then if I'd like, I can go ahead and edit the title. So I called this movie ratings. Sorry, I turned the page. Movie ratings by frequency. And there you go. What's nice about it is that you can actually copy and paste this graph into like a Word document or a Google document. That's what's kind of nice about doing it this way. It's quick, it's easy. It really understands how to label the categories and the axes for you, but you could always change them too if something is not done properly. There's a lot of control where you can edit the chart and change things on it. So I encourage you to go ahead. You can like look at the categories and kind of play around it. It can be a little bit fun when you want to do that. Okay, so let me go ahead and we're going to go back to the notes. And let's try another example. This time we're going to do quantitative data. And as you can see, they gave us some raw exam scores. This is a class at PCC, Portland Community College, because these notes were created initially by somebody up there. Okay, so we want to make a histogram, and they tell us they want us to use a bin width of 10 points, meaning the interval between the categories is going to go by tens. Okay, now I notice they were nice enough to put the scores from smallest to biggest for us, which means I don't go any lower than 31%. So I'm going to start my scores. So these will be the scores. And then this will be the frequency. Oops, that's supposed to be a CY. All right. And I'm probably going to need a decent amount of space here for this. So let me go ahead and erase that and draw that a little bit longer. Okay, so the first category is going to be the scores that are in the 30s. So I'm not going to go 30 to 40. I'm going to go 30 to 39. That way I'm assigning the 40 to be in the next category. So a lot of people will set up their categories like this. They'll go 30 to 40, 40 to 50, 50 to 60, but the problem is that 50 is being labeled twice and 40 is being labeled twice. So which category does it fall into? It makes more sense to go ahead and start the previous or end the category with the lower number, with the one right below. So 60 to 69. And the only exception to that is this last category. Oops, it's supposed to be 80 to 89. In the last category, I'm going to go ahead and go up to 100. And it makes sense when we're talking about exam scores because getting 100 lands it in the A category. And that's what we would be considering this last section of interval of categories to be. So they call them bins, but they can also be called intervals. That's another phrase to use, an interval. And I'm just going to count up how many is in each category. So for the frequency, we have only one in the first category, and then we have nothing in the next two categories. And we need to go ahead and include them on our graph to show that there's literally no person who scored in that range. Then we have 2 here in the 60s, 2 in the 70s, 6 in the 80s, and 4 in the A category, including that 100. And if I total this up, it does in fact total up to 15. Okay, so I'm going to make a histogram. And just like the bar graph, I'm going to make sure to label everything. The difference this time is I'm going to have intervals of numbers. So my first interval is going to start at 30, and then it's going to go up to 39. And then my next interval is going to start at 40 and then go up to 50 or 49. But then the next interval starts at 50. So you'll notice what I'm doing is I'm labeling these first categories. Those are what I'm labeling on the graph. Because each tick mark is going to represent the start of a new category. 80, 90, and then we'll end at 100. All right. We only go up to 6, so I'll just do tick marks up to 6. 1, 2, 3, 4, 5, 6. All right. Let's label the axes. So this is the exam score. And then these are the frequencies. And this would be Math 105 scores. Okay. So we had one person in the first category. So I'm going to make a box like that. 0 in the next two categories. So I'm going to leave those empty. And then we get up to the 60s. We get 2 in that category here. Make a box like that. Oops. I said 60s and then I did it on the wrong one. 60s. There we go. In the 70s, I have 2 again. In the 80s, I have the big category of 6. And then in the 90s, I have 4. And see how each rectangle is kind of butting up to the next rectangle. So it's implying that all the scores here are technically in the 30s. And then all the scores in here are from 60 all the way up to 70. And then the next category starts from 70 all the way up to 80 and so forth. So that's kind of the idea behind the histogram, is it allows us to kind of do these intervals of numbers. That's what we're representing when we graph this. It doesn't have to always be the case, but that's typically the reason we draw a histogram.